Okay, our last section of Chapter 7 is 7.6 on proportional lengths. So if you want to do this GSP activity on your own, you can just pause, go through, do the construction, go through steps 1 through 5 right here, and then you can try to fill out this triangle proportionality theorem. So go ahead and pause and do that. Okay, now I have actually already done it, so here is the Geometry Sketchpad. So this is what you should have done. You should have constructed triangle ACD, this big one, and then you would have had to construct a point on segment AC or on segment AD, create a line parallel, then I hid the line and I just made a segment, so I have these, so these two are parallel. And then I started measuring the segments that it asked for. So it asked to measure segment ED, mine's 3.49, BC 4.27, AE 2.44, and AB 2.99. So I'm measuring all these little pieces right here. And then it says, well, compare the values of the ratios from all these numbers. So I just did a whole bunch of ratios, and you can see that I have ratios that are congruent to each other. So I compared AD, the length of the big triangle, and then the length of the small triangle of the side length. So side length of AD, and then compares to AE as side length of AC compares to AB. So what do we notice? We notice that they are the same comparison. They have the same ratio. So AD is to AE as AC is to AB. Here's another one. I did DE is to DA as CB is to CA. So notice DE and CB are not side lengths of a triangle. Instead, they're just this portion, right? If it was cut off by a parallel line, it's just this portion right here. So we have ED and BC. So ED is to the whole length of the big triangle as BC is to the whole length of the big triangle. And then I just did, okay, what about these two segments? If I compare DE and AE and CB and AB, so big length is to small as the big space is to small. And what do I get? I get the same ratio. So DE is to AE as CB is to BA. Those are the same ratio. And that's the one that leads us to our triangle proportionality theorem over here. It says if a parallel line to one side of a triangle, so this is my parallel line to one side of a triangle, intersects the other two sides. So it intersects the other two sides at point E and at point B. Then it divides those sides, so it divides these sides right here proportionally. Right? So that's what I proved over here in my GSP. It divided those sides right here and right here proportionally. Or all of these, right, are showing examples of how it's dividing it proportionally. But really, these are the two we're looking at. Okay, so let's go down and look at this example. It says, based on the diagram below, state whether the proportions below are true or false. So FA is to HA as FB is to TB. So yeah, I did that one over here on the GSP activity. So the big side of the triangle is to this segment as the big side of the triangle is to the segment. So yes, this is true. Let's try the next one. Okay, so FH is to FT. So we're doing small is to small as HA is to TB. So can we compare the small side of the side of a small triangle to the side of a small triangle to the side that was cut off by the parallel lines to the side that was cut off by the parallel lines? Well, yeah, that's going to be these two statements just rearranged. So we went small part to small part equals big part to big part. So yes, that was consistent, so that's also true. Okay, then we do FH. Oops, let me erase here. So FH is to AB as AH is to FT. Okay, is there any type of comparison we have there? No, because this is an entire length of a triangle, and at no other place this would also have to be an entire length of a triangle, and they would have to be at the same sides. None of those parts correspond, so that's a false statement. That does not work. If I jump over here, so hopefully that was pretty obvious there. Okay, let's look at FT is to FH as FB is to FA. So notice I went right small to left small, right large to left large. So yes, that is going to be true. Okay, then we have, let me erase, FA is to FH as FT is to TB. So I had entire side, small side, or big triangle side, little triangle side, and then little triangle side, no. So those don't match up at all. So this is a false. And then finally, my last one. It says FA is to FB as AH is to TB. So that works, right? It's the entire side of one triangle to the entire opposite side of another triangle to the segment on the same side as the original and then segment over here. So yes, this works, that is true. Okay, so use this knowledge to solve for the missing variables here. So what does it say? So we're trying to find x, we're trying to find y. So by this triangle proportionality theorem, we know that it chops these sides proportionally. So the easiest one probably to solve for right now is y. So 10 is to y, right? Small segment is to larger segment, as small segment 8 is to larger segment 12. I do my cross product, 120 equals 8y. I divide each side by 8, so y equals 15. Okay, there's my y. That's the easier one. Now my x is slightly more complicated, and this is where the biggest errors come into this particular section. X is the entire length of the side of this smaller triangle. And it compares to 24, which is the entire length of the side of the large triangle. So I need to go back and compare a small side of the side of a small triangle to the side of an entire, the large triangle. So small triangle is to large triangle as small triangle is to large triangle. So notice not these pieces right here, not a chunk. You can't say 8 is to 12 as x is to 24 because 12 isn't the entire side of the large triangle. So we have to do small triangle is to large triangle side, and you can just put a 20 there, but I'm trying to emphasize the fact that you have to add those together. So small triangle side is to large triangle side as small triangle side is to large triangle side. Again, the most common mistake is to only put a 12. You have to put the 8 plus 12 here. So when I cross multiply, I would have 24 times 8 equals 20 times x, divide by 20. So you should use your calculator here. I don't have a calculator, so I'm going to try to do this in my head. Cancel 4, that's 48. So it looks like it should be 48 fifths. So if you get a decimal, that's fine, right? 48 fifths, 5 goes into that, 9 and 3/5 time, which should be 9.6 unless I have made an error in my calculation, which is very well possible, but I think 4 goes into that 5 times, 6 times 8, 48. So I think that's correct, but if I did make an error, let me know or let your teacher know and just verify that. Okay, so again, these parts are congruent, but also the side lengths are not congruent, my fault. They're proportional. So the segments are proportional or the side lengths are proportional. Okay, moving on, another GSP, oh no, not yet, sorry. Okay, what if 3 parallel lines are cut by 2 transversals? So 3 parallel lines are cut by 2 transversals. What's going to be true? Well, just what you'd expect. If 3 parallel lines cut 2 transversals, and they divide the transversals proportionally. So you can check that with GSP if you're not sure. Just make 3 parallel lines, cut them off, compare their ratios, and you'll see they are the same. So how do we set it up? Well, we say this part 7 is to the lower part 5, as this upper part 9 is to the lower part x. We cross multiply, 7x equals 45, divide by 7, therefore x equals 45 over 7. Right, so notice you're getting fraction answers, that's fine, just leave it be. That's 7 and 3/7, or you can get a decimal answer. That's fine. You can leave it in fraction form. No need to use your calculator, but if you already punched it into your calculator and got a decimal, that's fine. Just write that down. Okay, finally, we have our investigation 2. So go ahead and pause and try investigation 2 if you'd like to on your own. Okay, so investigation 2 should look something like this. So I have, you had to create a triangle ABC. So here's my triangle ABC. I constructed angle bisector, and then I labeled this point D where it intersected side BC. I had to measure, so I measured CD. CD is 10.31 on my diagram. BD is 5.58. And then I calculated CA and BA, and then I did the ratios. So CA is to BA, or AC is to AB, as DC is to DB. So notice that I should have done this on my other one, right? No matter what I do, what happens to my ratios here? If I move these lengths, those ratios still stay the same, right? So these ratios stay the same. So what did we do? We went from side length here to side length here. So large side length is to small side length is to this portion here cut off by the angle bisector. So I go back to the same side I started from. So if I started with CA, I have to go back to DC. So CA is to AB as CD is to BD. So what does the triangle angle bisector theorem say? It says a bisector of an angle in a triangle divides the opposite side into segments proportional to the other two sides. So it says a bisector, so looking at the diagram, this bisector AD in the triangle divides the opposite side. So the opposite side is BC. So it divides this opposite side into segments that are proportional to the other two sides of the triangle. So CD over BD is the same as CA over AB. Okay, so stop. Think about this. So seriously, stop. Think about it. Are the two triangles that are created by the angle bisector similar? So is this triangle ADC similar to triangle ADB? Think about that. Are they similar? The answer, hopefully, you're saying is no, right? Even though side CA is in the same proportion as side AB as CD is to BD, AD didn't change. This is a 1-to-1 ratio. So this does not have the same proportion. If I made this exactly a 2-to-2 ratio, how am I going to do that? There we go. So 2-to-1 ratio, sorry, so this side is twice as long as this side is twice as long as this, but this didn't get twice as long in the larger triangle as a small triangle, so they are not similar. Also, they're angles. There's no way these two angles right here are the same. Right? So if I measured all the angles, I would see that all the angles are not the same. And in order to have similar triangles, you need to have congruent angles. Okay, let's jump down to these bottom two examples. Try to finish in 15 minutes. So it says, state a proportion for each diagram, then solve for x. So from that theorem, I'm going to say that x is to A as G is to N. Right, so I go large and large, they have to match up here. So how do I solve for x? I just cross multiply here. So I get A times G divided by N. They're variables, but it doesn't matter. Sorry, this next one, you might want to pause and try it on your own, but if this whole thing is 10, then that means this little part here is 10 minus x, because this was x, which means this is 10 minus x. I'm going to pause to finish and then explain. Okay, so variety of proportions, but I set up 9 is to 6 as 10 minus x is to x. I cross multiply, I get 9x equals 6 times 10 minus x. I distribute my 6, then I add my 6x over here, so I get 15x equals 60, therefore x equals 4. As long as you have this cross product, it doesn't matter how you set it up here. If your cross product is the same and you got the right answer, you could have done 9 is to 10 minus x is 6 is to x.